From the icy glaciers in the Arctic to the vast jungles of South America, the Earth today has widely varying climates. But this has not always been the case. And 650 million years ago, our planet was a snowball covered in glaciers as thick as 1.2 miles. New research suggests that an intense period of acid rain lasting 100,000 years could be responsible for melting the vast glaciers and pushing the Earth towards the environment we know today. Researchers from Peking University in Beijing suggest that intense chemical weathering was likely the cause of the end of the Mare-Known glaciation period. The period, which occurred from 635 to 650 million years ago, saw huge glaciers covering the entire planet in an event called the snowball Earth. Until now, there has been little evidence to show how this icy period came to an end. In their paper published in PNAS, the researchers, led by Kang-Jung Huang, wrote, according to the snowball Earth hypothesis, cap carbonate deposition was driven by intense continental weathering during deglaciation, but geochemical evidence is lacking. To understand what happened, the researchers reconstructed the history of chemical weathering during and following the end of the Mare-Known glaciation in South China. Their results suggest that the period may have come to an end as carbon dioxide and other greenhouse gases built up from volcanic activity. The high levels of carbon dioxide in the atmosphere led to very acidic rain, which would have washed over the continents and left chemical signatures in the surface rocks. Acid rain led to the development of cap carbonates, characteristic layers of rock that form when chalk is present in water. The researchers' chemical analysis of rocks in southern China showed there was direct evidence for chemical weathering, suggesting that the acid rain could have brought an end to the ice age. And the acid rainstorm wasn't simply an outburst over a few hours. The researchers believe that the downpour lasted hundreds of thousands of years towards the end of the Mare-Known period, pushing it out of its freezing state. The researchers added, our finding confirms intense chemical weathering at the onset of deglaciation. The deglaciation could in turn have led to the Cambrian explosion, a period beginning around 541 million years ago during which most major animal phyla appeared. As the glaciers melted, huge amounts of nutrients were released into the oceans. This caused oxygen levels to rise deep in the oceans as bacteria and other microbes flourished, resulting in more plankton. This plankton buried organic carbon in seafloor sediments when they died, causing the proportion of oxygen in the atmosphere to rise.